Hi, thank you, Jean-Philippe. Yes, when I was invited for this talk, I was asked to talk about what's trendy in machine learning right now, and there was so many possible options, which I will present here. So next slide, please. For example, we could talk about Honda with that new announce from 1 week ago. He stated that it will be the first one to go from level 2 self-driving cars from level 3. Next slide, please. We could talk also about self-training with the noisy students. It's a great new method from published in March 2020. Very interesting, quite groundbreaking. We could also talk about, in the next slide, please, the framework used in machine learning and see that right now we are using much more PyTorch than TensorFlow and what are the inputs from this change. Finally, we could talk also about facial recognition. In the next slides, please. Yeah. Which has been banned a few days ago in Portland and in other places in the world quite recently too. So as you can see, we can have plenty of topics, and I chose 3, not in this one. In the next slide, please. Which are natural language processing, a very trendy domain right now. I also wanted to give you concrete examples of how machine learning could be used to protect in cybersecurity. And the last part will be about ethics, which is growing to be a field in its own inside machine learning. So to talk about this today, in the next slide, please, with you, I'm Sacksick. I'm data scientist at CybelAngel, and I'm also Coorganiser at WiMLDS Paris. WiMLDS stands for Women in Machine Learning and Data Science. And so we can go on with natural language processing. The first thing I think is important in this field, please, in the next slide, is that today we are using models which have more and more parameters. What is a parameter in machine learning? It's a coefficient you have to compute to fit on your training data. And of course, to do that fitting, you have to do computation, and therefore there is a compute cost associated with the number of parameters. Next slide, please. For example, in this article, the cost of training NLP models, a concise overview, there is a quote I really like, which is just how much does it cost to train a model? Two correct answers are depends and a lot. And if you remember from the previous slide, the bigger model we have today is called GPT-3 and is 155 billion parameters. So if you have the estimate that for 1.5 billion parameters, it costs around $1 million, you understand that, well, it costed a lot, and it also means that you won't see tomorrow a new startup launching its brand new model. You have to be quite an established company already. Next slide, please. Talking about established company, for example, Facebook, which is of course doing a lot of NLP, it just released a new model which can translate one language to another without going through English. While so far, what we had to do, for example, if you wanted to translate from Chinese to Spanish, you had to go through English, like Chinese, English, and then English, Spanish. And of course, you understand from this that the quality of the translation is directly impacted because you will have the lack of the translation, the first phase and the second phase. So if you do only one phase, only one computation, you will have a better translation. So it's actually great news also for languages which are low spoken or less spoken than what we can see from English, for example. And this is this is also groundbreaking in this field. Next slide, please. From what I said, you understand that natural language processing is usually applied to natural language, which means human language, such as English, French, Chinese, Spanish, and so on. But recently, with this example from an article in 2020, we've started to see models dealing with languages which are actually not natural. They are code, it's code. And in this example, the authors present a model which can repair your program and which can help you to fix your program given the feedback made by the computer. So it's really impressive, and it shows that we will less and less require the grammatical phase as we can see in natural languages. Next slide, please. This is for natural language processing, and now I wanted to give you concrete cases of how you can apply machine learning to cyber protection. So my first example will be about fraud detection. If you go through Google Scholar, it's like Google but for research articles only, you see that it's mainly about credit cards fraud detection. So far, we start to see that the insurances are taking the topic, but it's still, this growth is still ongoing. Today, is the fraud detection field is very focused on credit cards and then bank troubles. Next slide, please. Of course, one very big field of use, one big use case of ML in cyber protection is about phishing. So as maybe you've been through this, you've seen that spamming went through an incredible rise during March 2020 due to COVID. And here is an example of a phishing message from Titian blog. And you see that it takes the new event as an excuse to do phishing. So if your model is not robust, if your model is too much used and overfit on previous data, this email is new to it and it won't detect it as being a spam. This shows the importance of having robust models, which means that having models which can do correct prediction, although the data incoming, the input data, doesn't really look like the data it has been trained on. If you do not have a perfectly robust model, what you can do is to do what we call online learning. When you do spam detection, what you are actually quite lucky because your users will tell you if it's a spam or not. They will do the labelization phase for you. So you can just retrain very fast. You just have to collect like 1 week of data and you can retrain, and your algorithm will know what's been through the last week, and it will be more able to protect your users in the coming week. Next slide, please. Another example, of course, is about detecting cyber attacks. So I just really like this example given in this blog post, which is called Anomaly Detection in the Eye of the Beholder. It shows you there that you can, what here in machine learning we would call that clustering, which you can group your cards with different rules. You can choose to have them by color or by value, and it will have different results. And actually, in machine learning, it's quite the same. It means that you will need to do your own definition of your business case, of your business objective. Maybe in your company, a system is working properly because it's in phase, coherent with your objective. But in another company, they won't define cyber attacks exactly the same way. So they won't. The success of this model won't be the same. It will, for example, miss an attack or block too much users. You have to adapt the model to your own use case, and you have to define business metrics to say if a model is behaving correctly. Next slide, please. The last example I would like to give you about how ML can be used in cyber protection is, of course, what I'm doing every day at CybelAngel. What we do at CybelAngel is that we do prevent from data leaks for our clients. So what we do is a comprehensive scanning of the web. And we are aiming at two things. We do only want to send qualified alerts to our clients, and we do not want to lose confidential documents which leaked. And here you see that it's actually impossible to have a machine learning algorithm going alone and meeting both objectives. If someone tells you they do with machine learning objective, it's actually not possible. You either have to protect too much or not enough if you're only using one solution. So the solution we've implemented is using both machine learning and a human eye. So they can help one another. They can help one another, and machine learning will do that we are not losing anything confidential, and the human eye will do that we do not send anything that is not qualified. Next slide, please. The last part I wanted to talk about here is about ethics. Why ethics? It's because it's while before it was something you would do if really you were caring about it, while now it's very frequent to see inside an article, well, I'm thinking about the impact of my models. Next slide, please. For example, the conferences NeurIPS and ICLR, which are very big conferences in machine learning, just published this year a code of ethics. So here you can see the example of ICLR code of ethics. If you read it, you understand that it's not incredible. It's quite actually just logical. Avoid harm, be honest, trustworthy, and transparent, for example. It's not incredible, as I said, but it's still something, and it asks the authors to think about the consequences of what they write in their papers. For example, it won't be allowed anymore to do facial recognition to predict if someone is LGBTQ, for example, because it would create harm, and it's not ethical. Next slide, please. So one field where we can see a lot of bias, as I said, in facial recognition, in computer vision, but also in natural language processing. And here is a great article, really. It shows that it's working on debiasing methods. So here, the purple points are words related to a female gender, like what we would say female gender, like queen or kitchen in a biased world. And the blue one, or green-blue one, are related to a man, masculine gender, such as king or money or power. Here you can see on the left side the representations of the world for the model in informatical wording. They are very separated. Then you applied the debiasing method, and you represent them, the words again, and you see that these clusters, they were very separated. They're a little bit less separated indeed, but it's not perfect. So it showed that actually this debiasing method, it's good to be working on it, but so far we are not able to completely debias the language. As I said, it's good to be working on it. And on next slide, I showed that there is a reminder that GPT-2 was really biased, and there apparently no work has been done to remove this bias in the new version. And in this Twitter feed made by Abubakar Abid, it showed that it's exactly the same as before. So not everyone is starting to work on this bias and on ethics yet. As a conclusion, I wanted to, in the next slide, please, I wanted to do a bonus part, which is I've been presenting how the ML can protect, but if the ML protected actually itself. So in this last slide, next slide, please, we can see that it's been taken seriously, and Gartner Research published this article. It's called AI as a Target and Tool, an Attacker's Perspective on ML. And I would like to remind you the example of the Tide chatbot. It was a chatbot made by Microsoft. It was released on Twitter, and it was supposed to learn how to interact and to learn how to speak with the interaction it had on Twitter. Unfortunately, some people start to interact with it with actually specific ideas, and the chatbot turned Nazi. So Microsoft had to turn it off at the end of the day. It was less, as I remember, I think it was in 16 hours they had to decide to turn it off. In this article from Gartner Research, they present all the adversarial ML threat matrix, where you can think. They help you to think about all the ways your ML algorithm could go bad and prevent it to protect it too. Thank you for your attention.